Ever wondered how AI could spot the difference between two nearly identical photos, or figure out why a video's camera moved between frames? That's the big challenge researchers are tackling with a new AI system called MiCo, short for multi-image contrast. Let's dive into how it works and why it's a game changer for visual reasoning. Here's the problem. Current AI models are great at understanding single images, like identifying a cat in a photo. But when you throw multiple images into the mix, like a video or a series of photos, they struggle. Imagine two zoo photos. One shows a gorilla inside a cage, the next a lion outside. A human would spot the shift in seconds. But traditional AI, it might miss the change entirely or get confused. Why? Because it's trained to analyze images individually, not compare them. That's where MiCo steps in. Instead of relying on human-labeled data, it teaches AI to reason across images by using the images themselves as clues. Think of it like giving a detective a magnifying glass and a notebook. MiCo helps the model spot tiny details, track changes, and connect the dots between frames. Here's how it works. MiCo uses something called contrastive learning. It creates triplets of images, two that are similar and one that's slightly different. For example, two frames from a video where the camera shifts, or two edited versions of the same photo. The AI's job? Figure out which images match and why. But here's the twist. The images are augmented with random tweaks, like crops, rotations, or resizes. This forces the model to focus on subtle details, not shortcuts. It's like training a detective to notice a single thread in a sweater, not just the color of the fabric. What makes MiCo special is its self-supervised approach. Instead of needing humans to label data, it learns by comparing images on its own. This cuts costs and makes the system more scalable. Think of it as teaching a child to solve puzzles without giving them the answers, just the tools to figure it out. And the results? MiCo outperforms existing models on tasks like tracking objects in videos or spotting tiny changes in scenes. It can predict camera movements, group similar images, or even help doctors spot subtle differences in medical scans. Imagine an AI that could analyze a crime scene video and notice a missing object, or flag a tumor that's grown between scans. So what's the big picture? MiCo isn't just about better image analysis, it's about teaching AI to think like humans. By focusing on visual contrasts and logical reasoning, it bridges a critical gap in how machines understand the world. As this tech evolves, we'll see smarter systems in everything from healthcare to self-driving cars. Next time you watch a video or flip through photos, think about the hidden clues. What if an AI could spot them and learn from them? Thanks for watching. If you want to see how MiCo solves these puzzles step by step, hit that subscribe button. And let me know in the comments, what visual tasks do you think AI should master next? Ever wondered how AI can really see and reason about the world? Let's talk about a model that's rewriting the rules, MiCo. This isn't your average image recognizer. It's like giving a robot a detective's notebook, letting it piece together clues from photos and logic puzzles. Imagine you're shown 3 Lego cars. One looks like a Lamborghini, another has a different grille, and the third has gold wheels. How do you tell if they're different toys? MiCo doesn't just guess, it breaks it down. It checks details like assembly, color, and design, step by step. This isn't about surface-level stuff like shape or color. It's about understanding what those elements mean. In tests, MiCo crushed tasks that demand real reasoning, like solving math problems hidden in images or figuring out if two photos show the same object from different angles. It even tackled jigsaw puzzles by spotting spatial clues, like how a missing piece might fit based on the scene's overall structure. Another challenge: decoding letter patterns. It noticed that I follow a every fourth letter rule, then used that logic to find the next in a sequence. This isn't just pattern recognition, it's abstract reasoning, like an IQ test for machines. But here's the kicker: MiCo doesn't rely on humans labeling millions of images. Instead, it learns from intrinsic visual clues, like how a photo changes when you flip it or add noise. By comparing these shifts, it figures out what matters without needing human input. This means it can adapt to new tasks faster and work in areas where labeled data is scarce. How does it stack up against others? In benchmarks like MMStar and Blink, MiCo outperformed strong models like QN2, 5VL7B at reasoning tasks. But it's not perfect. When it comes to super detailed work, like counting specific objects or spotting tiny visual differences, it sometimes stumbles. That's a key takeaway. MiCo shines at big picture thinking, but fine-grained details still need work. Oh, and here's a cool twist. MiCo's approach is different from methods like noisy rollout. While both use image tweaks, MiCo focuses on weak augmentations. Think subtle changes, not wild distortions. This helps it avoid getting confused by overly altered images, letting it tackle harder examples with clearer logic. But not every experiment worked. The team tried tricks like weighting answers by the models, confidence, or balancing data with importance sampling. None of these improved results. Sometimes they made things worse. Science is all about trial and error, right? So what's next? MiCo's ability to reason about visuals could revolutionize fields from agriculture to language research. But with great power comes great responsibility. Its sharp eye for detail could also be misused. The solution: transparency, safeguards, and keeping humans in the loop for critical decisions. MiCo isn't just a tool, It's a step toward AI that's not only smart but also thoughtful. The future isn't just about what machines can do. It's about how we guide them to do it wisely. Stay curious and let's keep pushing boundaries responsibly.